More than 500,000 different compounds form in the combustion chamber of a refuse incineration plant. Even computers can't simulate their chemical reactions. It's absolutely impossible to determine the composition of the flue gases. The majority of the substances emitted is not known, either qualitatively or quantitatively. After incineration, approximately 40% of the refuse to be disposed of remains in the form of ash, slag, and highly toxic dust. Major technical resources are required to dispose of this residual waste. From waste materials, Thermoselect recovers synthesis gas, mineral substances and metals. Using the Thermoselect process, emissions remain significantly below all statutory threshold limits. Thermoselect achieves this ecological advantage by combining and optimizing technologies which have proved themselves in practice over a number of decades, and by employing high-temperature gasification using oxygen as a medium. The wastes to be disposed of, including industrial, household and hazardous wastes, as well as sludges and industrial scrap, are mechanically compacted without pre-treatment to a fraction of their original volume. Under high pressure, the compacted waste is formed into gas-tight plugs and pressed into the degasification tunnel. Here, in the absence of air and under pressure and heat, organic matter is degasified and converted into carbon. Inorganic substances, such as metals and minerals, are encased in the carbon. Together with the carbon, they're fed into a high-temperature reactor. Oxygen is added in measured quantities, and at temperatures of up to 2000 degrees Celsius, the carbon is gasified. Chlorinated hydrocarbons are safely destroyed. Metallic and mineral constituents are liquefied. As opposed to conventional refuse incineration, the Thermoselect process homogeneously binds harmful substances into the liquefied metallic and mineral constituents. By shock cooling the synthesis gas, Thermoselect eliminates de novo synthesis of dioxins and furans. A thorough cleaning process ensures that residual pollutants are absorbed or condensed. The purity of the synthesis gas corresponds to that of natural gas. In the adjacent homogenization channel, the liquefied mineral and metallic constituents are transformed at a temperature of 1600 degrees Celsius into secondary raw materials. The granulated mineral substances are used as gravel substitute in concrete. Metals are separated out and supplied to the metalworking industry. The success of any waste disposal concept is measured by its environmental impact, the quality and quantity of residual waste, and the costs involved. The Thermoselect process produces no ash, slag or dust. It guarantees total destruction of all dioxins and furans. From waste materials, Thermoselect recovers synthesis gas, mineral substances and metals. The synthesis gas is used to produce electricity and heat. and to chemically synthesize methanol and hydrogen for alternative drive systems.
Throttling back up to 104%. Engines showing 104%.
Millions of years ago, in the absence of air and by the action of pressure and heat, organic matter was converted into coal. In the first half of the 20th century, coal was gasified on an industrial basis. Thermoselect has adapted the natural method of coal formation and coal gasification to develop a technical process which allows the various materials and the energy contained in refuse to be recovered and utilized.